4-3, prime factorization. First, we need to look at what makes a number prime, composite, or the exception neither. We're going to give them some definitions. Hopefully they will be reviewed for you. A prime number prime number has exactly two factors, the number 1 and itself. A composite number simply has more than two factors. And an exception, neither. So we have exactly two factors, we have more than two factors. The exception is neither numbers have exactly one factor, and there are only two of them, whereas prime numbers and composite numbers, there are extensive lists of both. But two numbers have exactly one factor. The number 1 and the number 0 have exactly one factor. Today we're going to look at something called prime factorization. It's a way of writing the factors of a number. It's also called the product of primes. It's a different way of listing the factors of a number. So we have the number 24 on the board. We're going to find the prime factorization. 24, relatively easy, can be 1 and 24, 2 and 12, 3 and 8, or 4 and 6. 1 and 24 will do you no good because it doesn't break the 24 down into any of its smaller parts. So we won't use the 21 and 24. In fact, you won't use that for any number unless it's a prime number, and you'll use it to just show that it is a prime number. So we have choices of 2 times 12, 3 times 8, or 4 times 6. They all work. They're all as good as the next. However, I'm going to advise you to pick the 2 and the 12 because 2 is the smallest prime number that goes into 24. So I always want you to choose the smallest prime number that goes into the one you're looking for. And I'm going to underline it because for me, that's the end of that branch off of this factor tree. We can't break 2 down because 2 is a prime number. So now we have 12 we're going to look at. 12 can be broken into, from the previous board, 1 and 12, 2 and 6, and 3 and 4. Again, the 1 and 12 is not going to do us any good, so we're going to eliminate it from possibilities. So that leaves 2 and 6 and 3 and 4. We should use the 2 and the 6 because 2 is the smallest prime number that goes into 12. So now we have 6. 6 can be broken into 1 and 6 and 2 and 3. 1 and 6 does us no good because it's the factors of 6, but we can use 2 and 3, and they happen to be prime numbers. So 24 can be written as the product of primes, which is 2 times 2 times 2 times 3. We can rewrite it that way. You'll notice that 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24. So we can write 24 as the product of prime numbers. It's a different way of writing out the list of factors for 24. We have the factors of 24 on the right, 1 and 24, 2 and 12, 3 and 8, and 4 and 6. We also have the prime factorization as 2 times 2 times 2 times 3. You should look at the tree for 24 and notice that the left-hand branches of the tree are all prime numbers, and the right-hand branches, until the very end, are composite numbers. Interesting to note about the prime numbers, if you look at the branches on the left, working at the highest branch and working down the tree around to the right in this fashion, they are in order from least to greatest. That makes it easy so that when we write our factor list as an answer, our prime factorization, It shows us how to put them in order. That's why I would like you to go with the smallest prime number on the left and its corresponding factor on the right of the tree. One other thing that you can do today, because it is an extension of what we did yesterday, is we can rewrite 24 in exponential form. There are 3 2's. 2 to the third power times 3 to the first power. You don't need to write the 1 with the 3. It doesn't hurt. Next board, we're going to throw in some negative numbers. We have negative 48 to work with. Kind of difficult because it's a negative number. There's an easy solution, and you've kind of already done this before. We are actually going to break negative 48 into negative 1 times positive 48. And that takes care of the negative sign. Now we have positive 48. So what is the smallest prime number that goes into positive 48? 2. It's an even number. 2 times 24. We can break the 24 from the previous board into 2 times 12, 2 being a prime number, 12 being composite. 12 can be broken into 2 times 6. 2 is a prime number. 6 is composite. And then 6 can finally be broken into 2 times 3. And both of those numbers are prime numbers. We can rewrite negative 48 in prime factorization as negative 1 times 1, 2, 3, 4 2's. 1, 2, 3, 4 2's, and a 3. Today, it's beneficial to rewrite negative 48 as the product of primes in exponential form, which is negative 1 times 2 to the fourth power times 3 to the first power. However, after today, you're not going to want to write it in exponential form. Today, writing it in exponential form is just more practice of getting you to go back and forth between exponential form and expanded form. Tomorrow, expanded form is definitely the way you're going to want to view your work. Next board, we have 8ab squared. Now we're going to have variables. First board was a plain number. Second board was negatives. Third board has variables. Not as difficult as you might think. We're going to take the ab squared off. Move it off to the side, and we're only going to work with the 8. 8 can be broken into what? 8 times 1, 2 times 4. We will go with 2 times 4. 2 is a prime number. 4 is not. It's a composite. 4 can be broken down into 2 times 2, which are both prime numbers. 8 can be written as 2 times 2 times 2. You remember the variable stuff that we had at the beginning of the problem that we took off? All you're going to do now is just stick it back on the end. AB squared. You could write it if you want, and this is a hint because you're going to want to write it this way tomorrow. 2 times 2 times 2 times A times B times B. We want things in expanded form tomorrow. For today, what's written above is fine. If you wish to change it to all exponential form, it would be 2 to the third power AB squared. Your homework today is going to be on page 162. You're going to do problems 14 to 42, the evens.